Hi. Today we learn what is conditional probability and its properties and some application of conditional probability. Suppose we take a sample space as grade level. This is your sample space. So here some students opted mathematics, some of the students opted IP, some students opted maths and IP, some of the students not opted maths as well as IP. Suppose there are 4 students opted maths and IP, 7 students opted maths, 10 students opted IP, so 8 students were not opted maths or IP. So if we ask how many students are opted maths? How many students are opted maths? Here you can see that this 3 and 4. This is the total number of students who opted maths. So we will say that find the probability that the student opted maths. That means number of students who opted as maths, suppose I am taking this as A, this as B, and number of students in sample space N of S. This is your probability of maths students. So from the figure we can see that N of A means 3 plus 4, that is 7, divided by N of S. N of S means total number of students in the grade level. 6 plus 4, 10 plus 3, 13 plus 8, 21. So this is the probability of who opted maths. Now how many students are opted IP? So that means probability of students who opted IP. So suppose we have taken IP as B, so probability of B equal to N of B divided by N of S. So N of B is equal to 10 divided by N of S is 21. This is what we have learned probability means. Now see, here we have asked number of students who opted maths. That we have taken as 4 plus 3, 7. Suppose this question I am changing as how many maths students are opted IP. So how many maths students are opted IP? So this is your maths students. In this maths students, how many students are taken IP? That means 4 students are taken the IP who has taken mass. So here we can say that, we can see that here sample space is decreasing to mass, because we are asking how many mass students are opted IP. So we have to see only here mass students. We are not going in sample space. So here sample space is decreased to mass. So we will say that one is, this will write as probability of IP students who opted mass. So here how many IP students are there? 4 students. In total mass students. Mass students is how many? 4 plus 3, 7. So we can see that when is mass student is given, what is the probability of IP? So probability of students who opted IP who are taken the mass. So you can see very clearly that your sample space is decreasing to your given, what is given. So you can see here, if this question I am asking, how many physics students IP students are opted mass. That means how many IP students are opted mass. So given is already IP students, sample space is decreasing to IP, and we want to find out probability of mass students. So here is coming, IP means this set. So 6 plus 4, 10. That is your sample space. Out of that, how many mass is there? So there are 4 students. So 4 by 10, that is 2 by 5. So we can say A and B are 2 events associated with the sample space of a random experiment the conditional probability of the event A, given that B has occurred. That means probability of A given B. So probability of A given B. So here in this question you will see here probability of IP given mass. Probability of mass given IP. Here mass students who has taken the IP. So you can see from the figure IP we have taken as 4. That means in mass students, this is your mass students. That is your A. So we are taking N of A, that is given your sample space, and IP means this 4 students are taken from mass. So we will say here this region is here A intersection B. So N of A intersection B divided by n of A. Now similarly here you see here mass given IP. IP means here probability of B. So we are taking n of B. Now mass means what? How many is taken? Intersection. So number of elements in intersection. So this is here probability of mass, that means A given B. This is what we are taking, probability of B given A. So probability of B given A means n of A intersection B divided by n of A. Probability of A given B means n of A intersection divided by n of B. This is what your conditional probability. Probability of A given B equal to n of A intersection B divided by n of B. Now here I can write or I can divide both numerator and denominator by n of S, sample space. See, n of B divided by n of S. Both sides we can divide, numerator and denominator divided by n of S. So this is your probability of A intersection B divided by n of B by n of S is probability of B. So you got it. Probability of A given B means probability of A intersection B divided by probability of B. This, of course, we know that one is probability of B should be not equal to 0, as division by 0 is not defined. Now see this one, A given B, we have written A intersection B by B. Now in previous example you see here probability of A given B, n of A intersection B divided by n of B. B given A means n of A intersection B divided by n of A. So we can write here as probability of B given A means again probability of A intersection B divided by probability of A. So here probability of A is not equal to 0. So this is what conditional probability means. Now suppose we will take another set. Again grade 11 sample space we are taking. There are one set we are taking as mass, suppose, and here IP students are inside subset of mass. So therefore IP there were 4 and the mass therefore 10, and A students suppose not studying both. Now here you see mass, suppose I am taking this is your mass, this is your IP. Suppose this as A, this as your B set. Now what is probability of A given B? So we know that one, probability of A intersection B divided by probability of B. Now from figure you see that A intersection B. So what is A intersection B? This set intersection this set. So that is your set B only. So that is your probability of B only divided by probability of B. That means this is equal to what? 1. So here probability of A given B equal to is coming as 1. Now suppose probability of B given A you want to find out. Again probability of A intersection B divided by probability of A. So here probability of A intersection B is coming is 4. Probability of A, this students. So that is what? 6 plus 4, 10. So n of A divided by n of B. So this is what? 2 by 5. Now suppose we are taking a mutually exclusive events. This both mass and IP are mutually exclusive. That means it's a separate sets like this. So this is your mass, this is your IP strings. So this is A we are taking, this is as B. So here is suppose 2, this is given as 6, there were 4 students. So how many mass students are opted physics? How many mass students are opted IP? So here mass students, that is given, that is A is given, you want how many are opted IP, that means B given A. So here you see that mass students, how many mass students are opted IP. So there were 2 mass students, how many of them opted IP? No students opted, mass students are opted IP because it's mutually exclusive, so it is 0. 0 by 2, 0. Now how many IP students are opted mass? So, how many IP students? Given is IP. How many IP students are opted mass? So, probability of IP means B, A given B. So, how many IP students? Total 6. How many mass students are there? No mass students. So, it's coming 0. So in mutually exclusive events, you are getting probability of A given B is 0, probability of B given A also 0. Now you can see very clearly that probability of A given B means your sample space is decreasing to B. Whatever is given B, B is what here? IP. So this is given, then what is the probability? So here total sample space is what actually? 6 plus 4, 10 plus 2, 12. So there were 12 sample space. Out of instead of that 12, sample space is decreased to 6. Similarly here sample space is decreased to 2. So that is the difference between original probability and the conditional probability. Now suppose I will take one big set. Instead of 2 sets, we will draw 3 sets suppose. Suppose we will take as mass, physics and chemistry. Mass, physics and chemistry. This is your sample space. So there were 5 students here, there were 4 students, 6, then 2, 3, 7, 9, 8. Now suppose you want to find out probability of physics students given that chemistry. So this means how many chemistry students are taken the physics. So here it is chemistry means we are getting this total. So 9 plus 7, 16 plus 5, 21 plus 3, 24. So total sample space is 24. How many physics? So physics means this two region. So this both is chemistry including chemistry. So 7 plus 5, that is coming 12. So 1 by 2. Now suppose I am saying that probability of all three subjects. Given that two subjects, the number of students who opted two subjects is given, then what is the probability that the all students are taken three subjects? Now here you see here two subjects means these are the region, this region, this region, this region. So 3 plus 7, 10, 15 plus 4, 19. So this is 92 subjects. Now in this 19 students, how many students are taken? 3 subjects. So 3 subjects is taken that here you see is coming as 5. All 3 subjects is taken in this region. So 5 by 19. Now another question, suppose probability of math students and physics students. Maths and physics is taken given that do not do chemistry. Chemistry is not taken, but now careful here. Do not do chemistry means this is your chemistry part. Except this remaining all that is given. So what is that? You can see that except chemistry, remaining all. So you will get it what? 1, 2, 3, 4 also. This 8 also coming because it is not taken any subject. 8 number of students not taken any of this subject. But we are saying do not do chemistry means that 8 also included. So your sample space 2, 4, 6 and 8 also will come. Now maths and physics. Maths and physics is coming. Do not do chemistry. So this red color we will not consider. Other maths and physics, how many are the? 4 students. So we will write it as that 4. So this is equal to 4 divided by 20. So that is equal to 1 by 5. Now we will see some properties also. Property 1 we will take as probability of A given S. So here it is S means it stands for sample space. A is your event. So A given S means it is always what? A only. Probability of A. Definition of probability is what? Number of students taken favorable to A divided by number of students in sample space. So immediately we can say this is what? Probability of A only. But to see that our definition is saying that what? Probability of A intersection S divided by probability of S. This is what? Conditional probability. Now event and sample space intersection always A only. So probability of A divided by probability of S. This is equal to probability of A. This is the first property. Probability of A given S equal to probability of A. Now second probability, probability of S given A means what? Now here again according to definition, S intersection A divided by probability of A. Now S intersection A is probability of A, that is again probability of A, that is equal to 1. So we will get it second property probability of S given A equal to 1. Now third property, probability of A union B given F equal to probability of A given F plus probability of B given F minus probability of A intersection B given F. This already familiar equation. We know that A union B means probability of A plus probability of B minus probability of A intersection B. The given F is there, so we can directly write it. Now, if both are mutually exclusive events, then probability of A union B given F equal to probability of A given F plus probability of B given F. If A and B are disjoint. Sets or evens, we will say probability, so it's evens. Now, fourth property, we can write it as probability of A dash given B, not A given B, equal to 1 minus probability of A given B. We know probability of S given B equal to 1. This is a property, second property we have already proved that probability of S given A equal to 1. So we can take here probability of S given B also 1. So immediately we can say that A union A dash is always equal to your complete set, that is your sample space. So therefore probability of A union A complement also is equal to given 1. A union A complement given B is also equal to 1. But A union A complement we can write as probability of A complement B, A given B plus probability of A complement given B equal to 1. Since A and A complement are mutually exclusive events, therefore A given B plus A complement given B is equal to 1. Therefore, probability of A complement given B equal to this A given B we can take in right hand side 1 minus probability of A given B. So this is. Now see the first question. In a certain school, 20% of the students failed in English, 50% of students failed in mathematics, 10% failed in both English and mathematics. So if you mark in this one, set English and mathematics. English, mathematics. So 10% students probability is given, 10% fail in both English and mathematics. 20% students failed in English. So this is 20%, 10% we have already marked. So this is 10% again, remaining 10. 15% students failed in mathematics. So 10 already we marked. So this will be 5%. Now what is the probability that he also failed in mathematics? So that means you want to find out if he failed in English. So it is given. So this is your sample space, English given. Then what is the probability he also failed in mathematics? So here we know that one n of m intersection E divided by n of E. So this is equal to, we know that one probability of m intersection E divided by probability of E. That is equal to 10% divided by probability of E is 20%. So this is 10 by 20. So it's 1 by 2. Now here probability of A complement is given. Probability of B is given. Probability of B given A is given. You want to find out probability of A given B. Now A given B means probability of A intersection B divided by probability of B. That means we want to find out probability of A intersection B is what? But here we know that probability of B given A is given 0.5. This means probability of A intersection B divided by probability of A. So we can write it immediately. Probability of A intersection B equal to probability of A into 0.5. But A complement is given 0.7. So immediately probability of A is what? 0.3. Because sum of those is equal to 1. So this is equal to 0.15. So this is 0.15 divided by probability of B, that is 0.7. So it's coming 15 by multiplied by 100, so 15, so it's divided by 70. So 5 is 3 times, 5 is 14 times, 3 by 14. This question you see, if A and B are two events such that probability of A equal to 0.2, probability of B equal to 0.4, A union B 0.5, then what is the value of probability of A given B? We want the probability of A given B. That is probability of A intersection B divided by probability of B. B we know already. Now A union B is given. So we know that probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. So A union B is given 0.5, 0.2, 0.4 minus probability of A intersection B. So therefore probability of A intersection B equal to this 0.6, 0.2 plus 0.6 minus 0.5, that is equal to 0.1. So this equal to 0.1 divided by probability of B is 0.4. So 1 by 4. Next question. Mother, father and son line up at random for a family photo. If A and B are two events, A is son on one end. Son on one end. This can be left side or right side. Father in the middle. You want to find out probability of B given A. Now see here, if A and B are two events, A is son on one end and father in the middle, find probability of B given A. That means if son is on one end, then what is the probability of getting father in the middle? So one is son is middle end means A. Son is A. Father, mother. Or mother, father. This both son is in one end. Then son can be here also, this side and so father, mother, mother, father, son. These are the 4 cases where is coming, son is in end. So, in this 4 case, how many times father is in the middle? Other one is here, here another case. So, these 2 cases coming favorable to B, father in the middle. So, 2 divided by A. A means end. End is coming, son is in end, total 4 cases. So, 2 by 4. Now, you see here sample space is decreasing. Otherwise, we know that 3 object is taken means total 6 will come. So, here it is coming 4 only. That means decreasing that sample space. This is what I have explained conditional probability means. So, it is 1 by 2. Now, see next question. A die is thrown twice and the sum of the number appear is observed to be 6. So, sum is given as 6. What is the conditional probability that number 4 has appeared at least 1? So, sum is 6 is given. B means number 4 appeared at least once. So, sum is 6, this is given. What are the possibility that when a die is thrown, sum is getting 6? So, 1, 5, this is one possibility. Then 2, 4. Then 3, 3. Then 4, 2. Then 5, 1. So, these are the possibility that when sum is given 6. So, we want to find out what is the condition of the number at least once. That means probability of B given A we want to get. So, A is given, sum is given, this is. So, this is a sample 1, 2, 3, 4, 5. Now, what is the favorable case? 4 appeared at least once. So, 4 is here once. Again one more. 2 cases, 4 is the other case, there is no 4. So, it's coming 2 by 5. Next question. A family has 2 children. What is the probability that both children are boys, given that at least one of them is boy? So, a family has 2 children. So, when we know that when one boy or girl, these are the possibility, or boy, girl, boy, girl. These are the possibility that when family 2 children means BB, BG, GB, G, G. Both children are boys. So both are boys you want to find out. So BA means both are boys. B means at least one of them is boys. So at least one of, so we want to find out B, both children are boys. So A you want to, both are boys, given that at least one of them is a boy. A given B we want. Now both are boys. This is only one case is there. B, B, here G, B, G, G. So both only one case is there. One. Now what else we want to get it? Here at least one of them is a boy. So one should be boy. 2 can be also boys. So one case is the BB, BG, GB. One boy is there. But when it's taking GG, both are girls. That is not possible. So this 3 case, 1 by 3. Now, if you write this one as sample space, then also we will get the same answer. You see that when you write a sample space is what? BB, BG, GB, GG. These are the 4 cases happening that both are boys. So A is both are boys is taken. So at least one of them boy, that is what B is what favorable case is coming is what at least one of them is a boy. So BB, BG and GB. At least one of them. In this, there are 3 cases. At least one of them is a boy. It is given. In this one, how many are there? Both are boys. Only one case is girl. So 1 by 3. So this way also we can do it, or using tree diagram also we can do it. Thank you.